Hey everyone, ready for a deep dive into something pretty wild? We're going to be talking about quantum mechanics and consciousness today. Two pretty mind-blowing topics on their own right.
Absolutely.
Well, we've got these two articles that suggest they might actually be connected, like closer than we ever imagined.
Yeah, some pretty groundbreaking stuff.
The first article is from Scientific American. Consciousness might hide in our brain's electric fields.
Ooh, that's a good one.
Right. So it's basically saying those electrical fields in our brains, the ones generated by all those neurons firing,
Yeah,
they might be way more important to consciousness than we thought.
definitely more than just side effects.
Exactly. It challenges the whole traditional focus on neurons and synapses.
Mm,
Like maybe it's not just about those individual signals.
right. It's like, instead of looking at each individual instrument in an orchestra, we need to step back and hear the entire symphony.
I like that analogy.
Yeah.
So this article talks about an experiment. Let me see. Dominique Duran's lab at Case Western Reserve University. They took a slice of a mouse hippocampus, and they measured the electrical potential. And get this, they cut the slice, like severed it,
Wow.
but the voltage barely changed.
That's interesting.
So that suggests those electrical fields, they're influencing things beyond just the individual neurons.
But a hidden communication network.
Yeah. And get this, they could be super fast, like way faster than neural firing.
Oh, yeah, I read that too.
Something like 5,000 times faster.
That's incredible.
Right. So something that takes a whole second to travel across the brain with neurons could happen in just a few milliseconds with these fields.
So like a thought could zip across the brain in an instant.
Exactly. And that makes me think about all those complex cognitive processes that seem to happen way too fast for traditional neural models.
Absolutely.
Like we've discovered a neural superhighway that
Yeah.
we didn't even know existed.
It really changes the way we think about how the brain works.
Right. And, the author of this article, Tanlin Hunt, she actually suggests these ephaptic field effects.
Mhm.
They might be the primary mechanism for consciousness, not just some secondary thing.
Wow, that's a big claim.
It is. And there's actually another paper that supports this by Kostas Anastasiou and Christoph Koch. They argue that even if synapses aren't super fast, these fields could be the key to coordinating everything. The whole symphony of consciousness.
That would change everything, wouldn't it?
It really would.
Mhm.
Makes you wonder what else we're missing.
Absolutely.
Like, are we just scratching the surface of how our brains really work?
I think so.
This is getting really interesting.
I know, right?
Okay, so we've got this idea of electric fields being central to consciousness. But hold on to your hats, because the next article dives even deeper into the quantum realm.
This is where it's really wild.
I know. It's from SciTech Daily. And the title is Groundbreaking Study Affirms Quantum Basis for Consciousness, a Paradigm Shift in Understanding Human Nature.
Wow, they're not holding back, are they?
No, they are not. And this study, it suggests that consciousness itself might be a quantum phenomenon.
Okay, so we're going full quantum now.
Full quantum.
All ready?
All right, let's dive in. So this study focuses on these tiny structures inside neurons called microtubules.
Microtubules?
Yeah, have you heard of those?
Yeah, I've come across them in my reading.
They're like little tubes that help give neurons their shape and transport stuff around.
Right, sort of like the scaffolding of the cell.
Exactly. But some scientists think they might be doing more than that. Like maybe they're involved in quantum processes. And those processes could be the key to consciousness.
That's interesting. So how does this study connect microtubules to consciousness?
Okay, so these researchers at Wellesley College, Professor Mike Wiest and his team, they did this experiment with rats. They gave some of the rats a drug that binds to microtubules, and then they exposed all the rats to anesthetic gas.
Okay, so they were basically messing with the microtubules to see if it affected how the anesthesia worked.
Exactly. And they found something pretty amazing. The rats who got the microtubule drug, it took them way longer to lose consciousness compared to the rats who didn't get the drug.
So the drug was somehow interfering with the anesthetic.
Right, and that suggests that the anesthetic might be working by acting on the microtubules.
And if the anesthetic affects consciousness, and it works by targeting microtubules, then maybe those microtubules are involved in consciousness somehow.
Exactly, and not just in any old way. They think it's happening at the quantum level.
Wow, that's a pretty big leap.
It is, but it's a fascinating possibility. I mean, Professor Wiest actually said, quote, "When it becomes accepted that the mind is a quantum phenomenon, we will have entered a new era in our understanding of what we are."
He really thinks this is a paradigm shift.
He does. And, if consciousness really is a quantum thing, It could have huge implications for medicine.
Oh, definitely.
Like, imagine if we could understand how anesthesia works at a quantum level.
We could make it safer, more effective.
Exactly. Or what about treating comas or mental illnesses?
Maybe even pain management.
It opens up so many possibilities.
It's mind-blowing.
It really is. So we've got electric fields and now microtubules, both potentially playing a key role in consciousness, and both possibly operating at the quantum level.
Are we starting to see a pattern here?
I think we might be.
This is getting really exciting.
I know, right? Okay, so we've explored two pretty mind-bending ideas so far. But hold on tight, because the next article takes us even deeper into the quantum realm.
Deeper.
Deeper. It's about something called quantum memory.
Quantum memory.
Yeah, it's pretty wild.
I'm intrigued.
It's all about how the very fabric of space-time might be able to store information, like a cosmic hard drive.
Okay, now you're just messing with me.
I'm serious. This article from Scientific American, how geometry revealed quantum memory. It lays it all out.
All right, I'm ready.
Let's dive in.
Great.
So quantum memory, it sounds like something straight out of science fiction, right?
It is, doesn't it?
But this article, it's suggesting it might be real.
And not just real, but like fundamental to the universe.
Right. Exactly. It's saying the very fabric of space-time might have a kind of memory. It can store information about what's happened in the past.
Okay, so not memory like we think of it, not like remembering your birthday or what you had for breakfast.
Right. It's more like a physical imprint left behind by quantum events.
Like a cosmic history book written in the fabric of reality.
I like that. A cosmic history book.
So this article talks about something called the Berry phase.
The Berry phase.
Yeah, it's named after physicist Michael Berry.
Okay.
He discovered that when a quantum particle goes through some kind of change, even if it ends up back in its original state, its wave function retains a memory of that change.
Hold on. So the particle itself doesn't change, but its wave function does.
Exactly. It's like the wave carries a hidden record of the particle's journey.
So it's like the wave is remembering something the particle itself doesn't.
In a way.
Yeah.
That's so strange.
It is strange, but it's also incredibly profound.
So how does this Berry phase thing actually work? Well, it has to do with the geometry of space-time. The way that space and time are curved and warped can influence the phase of a particle's wave function.
Okay, you're going to have to break that down for me.
Imagine you're taking a walk in a hilly landscape. You start at the bottom of a hill, and you walk all the way around it, back to your starting point.
Okay.
Now, even though you're back where you started, you still experience the shape of that hill. You've gone up and down, and that experience has changed you in some way.
Okay, I think I get that.
Well, it's kind of like that with quantum particles. Their wave function is like their experience of space-time, and that experience leaves a mark on them, even if they end up back in their original state.
So it's not memory like we think of it,
Yeah.
but it's still a form of information storage. It's like the universe itself is remembering what happened.
Exactly. And this Berry phase isn't just theoretical. It has real-world applications. It helps us understand things like the quantum Hall effect, which is important in solid-state physics.
So this quantum memory thing, it's not just some abstract idea. It's actually affecting how the universe works. Absolutely.
Wow. You know, it makes you wonder if something similar could be happening in our brains.
It does, doesn't it?
What if our memories aren't just stored in neurons, but also in the fabric of space-time itself?
That would be incredible.
It would change everything. I mean, we've already talked about electric fields and microtubules, and now this quantum memory thing. It's like every time we peel back a layer of the onion, we find something even more mind-blowing.
It's like the universe is full of hidden secrets.
And we're just starting to uncover them.
I think we are.
Well, on that note, I think we've reached the end of our deep dive for today. We've explored some pretty amazing concepts, from electric fields to microtubules to quantum memory, and we've seen how all of these things might be connected to the mystery of consciousness.
It's been a wild ride.
It has, but I think we're just getting started. There's still so much more to learn about the brain, about the universe, about ourselves.
I can't wait to see what we discover next.
Me too. Thanks for joining us on this deep dive. We'll catch you next time.